Math 3, Unit 3, Section 3. Today we're going to learn how to write an equation of a polynomial function. So, there's a couple things I notice about the graph, and hopefully you guys do too. So I'm going to wait and let you share out. What are some things that you notice right now about this graph? That was everything I needed to know. Okay, so if you didn't hear Destiny, what she said was she noticed that there are two X-intercepts. So I always like to kind of put bigger points there to make it very visible to me where my graph is touching the X-axis, because that gives us our what? When it's touching the axis, what does it give us? It gives us our factors, right? Okay, what would go in our parentheses? Okay, we're kind of working backwards right now. So what point is this at right here? This is at -3, 0. And also, Destiny mentioned that she noticed at this point right here, it is that bouncing or passing through? Bouncing, very good. This point right here, where is that at? 2, 0, good. And is that bouncing or passing through? Passing through. Okay, so if I am, there's another thing I should notice, and that is my end behavior. Okay? So if you're looking, what type of degree should this have? Degree should be odd, and my leading coefficient should be what? Positive. How do we know that? Odd because they're in opposite directions, right? And then leading coefficient is positive. Why? Good. And this is all stuff we just reviewed, right? And so all this information should make sense because we just talked through all this. So if I'm writing my equation, I have y equals a. And what am I going to put in? I'm putting a because I'm not sure what my leading coefficient is yet. But what would be my first factor? X plus 3. Why is it x plus 3? Because in order to make this equal to -3, it has to be the opposite, correct? Cell phone should be put away right now. Okay, now, what type of exponent should this function have? Squared. Could it also have to the 4th power? Yeah. Okay. Could it have to the 6th? Yes. So there's multiple equations that this graph could actually have. I'm going to go ahead and just put squared because that's normally what we're going to see. Okay? And so, and it's squared, why? Because it's bouncing. And when it's bouncing, it has an even exponent. Okay. We're good? Good. Okay, what will be my next factor? Good. X minus 2. And why is it x minus 2? Because when you set this equal to 0, it needs to make a positive 2. Now, what type of exponent will this factor have? Odd. So it could be 1. Just leave it like this. It could have 3. It could have 5. There's different options, right? We're going to leave it as 1. Okay. Now, how do you think I'm going to find what that a value is? Very good. You are going to plug in your y-intercept, okay, because here we have an x value and a y value, and we're going to put it in there, and we are going to solve for a. So when I do this, we're going to write this as -4 equals a, and then what's my value for x? 0. So I have 0 plus 3 squared times 0 minus 2. Yes? How did I know? Oh, yeah, they'll tell you here. And if they don't tell you for some reason, you know that your leading coefficient has to be positive, so you could just give it any positive value if you didn't know. But that's why I want us to actually see how to figure out the exact a value, and so that's why I gave you a value there. Okay? All right, so then 0 plus 3 is 3. And what is 3 squared? 9. So I have -4 equals a times 9 times, and what's 0 minus 2? -2. So I end up with -4 equals what? -18a. And then what would I do to get a by itself? divide by negative 18, and these cancel, and so I get A equals what? Positive or negative? Good, positive 2/9, because a negative divided by a negative makes a positive, and then we can reduce by 2. Okay, so my actual equation is y equals 2/9 x plus 3 squared times x minus 2. Any questions? Okay, so let's try another one. What is the first thing we should look at? X-intercepts. So let's go through. Let's make points at each of our x-intercepts so it's very clear as to how many x-intercepts we have and where they are. Because sometimes when you're just looking at that line there, it's really hard to see things. So I think if you're highlighting, making these points, it makes it very obvious. Okay, so how many x-intercepts do I have? 3. Okay, also, do I know what my y-intercept is right now? What is it? 0. So I'm not going to have to go in and find an a value because it's going to be 0. Do I know what type of degree this should be? What should it be? Even. How do you know? Very good. They're going in the same direction. Your end behavior is going in the same direction. Okay, my leading coefficient, should it be positive or negative? Negative. Why? Because it's going down. The right side is going down. The right side tells us what our leading coefficient is. Okay, so what ordered pair is this? What point is that? Very good. Negative 1, 0. The next point is at 0, 0. And this one is at 3, 0. Very good. So let's start writing our equation. Are you guys ready? Oh, what else did I not write that I should write? Passing through or bouncing, right? So this point is what? Passing through. 0, 0 is passing, and 3, 0 is very good. All right, so here we go for our equation. Y equals, what do I know should go in the front? A negative value. Would you guys, or we can start with the 0, 0, but if we're going through here, first of all, I know that my leading coefficient should be negative. We can put any negative number we want to, or we'll just put a negative 1. Okay, we could also think about this at the very end of the problem. You can think about the beginning, the end, but this one should be going down as a negative value. How do I write x minus, how do I write my factor when it equals negative 1? Good, x plus 1. Is that going to have an odd or an even power? Odd, because it's passing through. Good. How will I write the 0, 1? You could write it as x plus 0, or could you just write x? Yes. If you, no, well, you could just have this as an x. It's not going to be set, so you would just go x equals 0. Does that make sense? Okay, and then this third one, and then what type of exponent will this have? Odd, so I'm just going to leave it as 1. And then my last one should be x minus 3. And what type of exponent? An even. So we're going to go ahead and just give it a 2. Good, a square. And then I would simplify this because normally when we have just a plain x, it usually goes in the front. And so when I write this equation, I have y equals negative x, x plus 1, x minus 3 squared. And again, do we know why we have a negative in front? Because it should be going down. Manveer. You don't have to find a, you could find a on any of them really, but on this one, because it says we can write an equation, we don't have to have the exact value. And really because it's going through 0, 0 and my y-intercept is 0, 0, we just need to know that it's negative. Okay? And we'll go through some more, but when you have the y-intercept, it makes it easier to find the a value. Okay, so did I answer your question? Ish, not really. If it says an equation, you don't have to know the exact a value. If it says the equation, we have to know the exact a value, and we can plug in a point. Justin.
Is there a reason why you put negatives in front? Like, why wouldn't you just start off with the negative ones?
Okay, so you could do it at the end. Basically, you just, because the graph is going down, you know that your leading coefficient has to be negative. If the graph was going up, I would just know that my leading coefficient had to be positive. On this one, because we had a y-intercept value where we could plug it in and find the a value, this says the leading coefficient is positive, and when we worked through the problem, our a value was positive, so it worked out correctly. Okay? So for this one, you don't have to worry about the a value. It's just going to be -1. If you had, and if you go to Desmos, you can plug in values here, like if you did -5 or different values, and what's going to happen, it's going to make this go up more or down more. Because there's not marks on this graph, it's hard for us to find the exact a value. So just knowing that it's negative is fine. And also it's saying an equation, it doesn't have to be the exact equation. Okay. All right. And the reason why we can't use like these x-intercepts is because if I were to plug them in here, like if I plug this point into this equation, it would make a 0 and it cancels everything out, and so it's actually not helping you find the a value. So because I don't have another point on the graph, I can't find my exact a value. Where this one I could, because it was a point that was not an x-intercept. Yes, Denise. You don't have to. Basically, it's not that it's a negative x in front, although it is. It's really a -1 in front. And we have a negative in front, 1 in front, because we know our leading coefficient has to be negative. I just put it in the front because normally when you have your factored forms of equations, that single x or single number that's factored out always goes to the front. And so normally you don't have like an x in the middle. It just is the way it looks better.
So why for the first, why didn't we just plug in like a positive number for a like we did in the second one?
So we could, because they said they wanted an equation. You could just have any positive number in front. It wouldn't matter. Okay? But I just wanted to show you how to find the specific one if you have a specific point. So if they say an equation, you don't have to find the exact a value. You just need to make sure your leading coefficient is positive. If it says they want you to write its equation or the equation, then you have to find the exact. Okay? And here we go. Let's move on. Oh, linear equations. What type of degree would a linear equation have? Anybody know? How many, like, do you have an x squared ever in a linear equation? No. The degree is 1 because it just has one plane x. Our equation is usually like this, y equals ax, or y equals mx plus b. Sometimes you see it like that, or more times you see it like that. But notice the degree is 1. There's one x, there's no exponent. What's the degree on a quadratic? Squared, it's 2. Y equals ax squared for your quadratic functions. What about cubic functions? 3. Y equals ax to the 3rd. Quartic functions? 4. Very good. Y equals ax to the 4th power. Okay, so on this next one, they are telling us to sketch the polynomial function containing the given points and write its equation. They tell you it's quartic, so we know that means our degree has to be what? 4. Okay, so we have these points. Let's go ahead and mark them on our graph. -5, 0. 1, 2, 3, 4, 5. -5, 0. And then we have -1, 0. We have 0, 10. Where do I go for that one? Good, up 10. And so we just mark it, make that a 10. Can I find my exact a value on this problem? Yes, because I have a point that's not an x-intercept. Okay? 2, 0. And then 4, 0. Do you see how there are 4 x-intercepts? And our function is quartic, which means the degree is 4. So are any of these going to be bounces? No, because a bounce would mean I'd have an exponent of 2, right? And so I would only be able to have 3 points if I wanted one to have a bounce, which would be like an exponent of 2 and then 3, 4. Does that kind of make sense? So you have to look at how many x-intercepts you have. So if I am writing this out with the information we know, so right now I'm going to write y equals a, because I'm not sure about my a value yet, and then each of my parentheses. So my first parenthesis is going to be what? X plus 5. And we know none of these are going to have anything other than an odd exponent because this gives me my 4th power. Okay, this one is going to be what? X plus 1. Good. This one is? Good. This one is? Good. Is anybody confused by that so far? Yes. Well, two things is that because this is a 4th degree and I already have 4 points, that took care of all of my exponents. Because you know how this is 1 factor, 2 factors, 3 factors, 4. This gives me my 4th degree. So all of them are going to be odd. All of them are going to be the first power because this makes my 4th degree. None of them have to bounce in order to make it like a 5th degree or whatever. In fact, all of them will be 1. They couldn't even be 3 because if one of them was a 3, that would make a degree greater than 4. Okay, am I making more sense? All right, so what will be my next step here? Solve for A. And so my A value, we're going to be plugging in this ordered pair here, which is my 0, 10, X, and Y. So we're going to plug it in. 10 equals A times 0 plus 5 times 0 plus 1 times 0 minus 2 times 0 minus 4. Okay, also I want to remind you guys today's block day, so we go a little longer. Okay, till 7:50. Okay, so we simplify all these. So 10 equals A. 0 plus 5 is 5 times 0 plus 1 is 1. We get -2, and we get -4. So we multiply all that together. Very good. We get 10 equals 40A. And what would be my next step? Good. Divide by 40 to both sides. And perfect. A equals 1/4. So let's write our equation. Y equals 1/4, and then everything else is the same. Okay, and there isn't a plain X there in the middle, so I don't have to move things around. I can just leave it that way. But does this order really matter? No. This kind of goes back to our commutative property. If you're multiplying something, it doesn't matter the order in which you write it or multiply it. Okay, my end behavior should be what? Both positive. Since my leading coefficient is, we can write positive. We know that my right end behavior is going to end up going up. Since the degree is even, we know the left end behavior will also go up. Is everybody good there? We also know that all of these are going to end up passing through because they are all odd degrees. Okay, they all have a multiplicity of 1. Okay, so we go through here, it passes through, touches the 10, passes through, turns around, passes through. Questions? Okay, we're going to move on to the next one. Are you ready? There is a vocabulary word on this next example that you may not know. Does anybody know what it is? What word do you maybe not know? Tangent. Does anybody in here know what tangent means? So what tangent means,
6 of the time.
you're right, it was in that, like your SOHCAHTOA, but specifically with what we're dealing with right now, tangent means that it's going to touch without going through. So what does that actually tell us? Exactly. So tangent means there's a bounce. Okay? Also, so if you read this, sketch and graph the equation of a quartic function. So what degree is this going to have? Degree of 4. Whose graph passes through 0, 3. So let's go make a point at 0, 3. And it's tangent to the x-axis at negative 4, 0. So we're going to go to negative 4, 0. And since it's tangent there, what do we say about it? I did.
Yeah, you put lazy at
0, 3. Good job. That should be right there. Do you guys agree with that? Okay. And, okay, so it's a bounce, and then 2, 0 should also be a bounce. Can I find my specific a value on this problem? Okay, since it's a quartic function, okay, 4th degree, these bounces are actually going to be what value? Squared, 2, because 2 plus 2 makes 4. We should not have our cell phones out. Yes, good. Okay, so let's write our equation. Y equals A. What's going to be in my first parenthesis? X plus 4, Y. Good, negative 4, 0. So in order to make a negative 4 here, this has to be positive 4 in the parentheses. And it's going to be to the second power because it's bouncing. This one will be what? X minus 2 what? To the second power. Do these two add to make a degree of 4? Yes. Okay, so can I find my a value? Yes. What values do I use to find it? My 0, 3. This is my x, this is my y. 3 equals a times 0 plus 4 squared times 0 minus 2 squared. We end up with 3 equals a times 16 times 4, right? Negative 2 squared. This right here is a 4. This right here is negative 2, but you square it and it makes a positive 4. What's 16 times 4? So 3 equals 64a. My last step would be to divide by 64. Can 64 reduce with 3? No. What's the shortcut for 3's when you're checking? Add them together, and 6 plus 4 makes 10. 10 is not divisible by 3, so therefore this is not reducible. And so what will be my equation? Okay, so there's my equation. Now we need a graph. What should be my right end behavior? Positive infinity. Why? Leading coefficient's positive. Good. What should my left end behavior be? Why? The degree is even. So both of them are going in the same direction. Okay, this is the bounce. So that means it's touching here and it's bouncing up. It's going to go through that y-intercept there. Comes back down, and does it bounce again? Yes. So it worked out correctly. Okay, we're going to talk through this next one. We're not going to do the entire example, but we have a couple minutes, so we're going to finish up here. Okay, this one says it's a cubic polynomial, which means that the degree is 3. Okay, such that p of negative 2 equals p of 3, which equals 0. What they are telling you is, this is where, these are, remember, this is your x value and this is your y value. When you plug in the x of negative 2, you get a 0 on the y. When you plug in an x of 3, you get a 0 on y. So specifically, that tells me my x-intercepts. So that there's an x-intercept at negative 2, and an x-intercept at 3. Then it says P of 1 equals 5. So when x is 1, P is 5. So at 1, we're just going to go 1, 2, 3, 4, 5. So there is a point right there. Can I find my A value on this one? Yes, because I have a point that's not an x-intercept. The only time you can find the A value is when you have a point on your graph that's not the x-intercept. So when we are writing this out, y equals A. What's my first parenthesis? Ask me. Good, so we'll talk about it here in just a minute, okay? All right, so the degree we know is cubic. That's how we know 3. So we have x plus 2. Is everybody okay with that? And then we also have x minus 3. Okay, so we have to think a little bit, but we don't know if this bounce should be here or here. But we know that one of them has to be a bounce, correct? So it really depends on our A value. And in my notes here, it says, oh, listen here. It says, and P of x is below the x-axis only when x is greater than 3. So where is x greater than 3? Right here, it's greater than 3, right? So it goes below the x-axis here. Which means that over here, it has to go above. Also, we know it's above because the degree is odd. They go in opposite directions. So do you see how I can already, like, it's going to be a bounce there and a passing through there. So that means that which one is squared? X plus 2 squared. So real quick, just to finish this up, this ordered pair we know was at 1, 5. So I'm going to plug in my x and y values here. 5 equals A times 1 plus 2 squared times 1 minus 3. 5 equals A times 3 squared is 9 times negative 2. 5 equals negative 18A. I know I'm going fast. You can go back and watch this later. That's what A equals. So my final equation is y equals negative 5 over 18 times x plus 2 squared times x minus 3. All right.